And we're live. This is Michael Finicaro on the AI Across the Product Lifecycle podcast. I'm joined today by Dennis Just of EMMI AI and Asparuh Stoyanov, I hope I got that right, of Keyword. Two really exciting startups in the simulation space. So Dennis, give us a little bit of your background and about EMMI AI.
Yeah, I'm more than happy to, and thanks for having us, Michael.
My pleasure.
Personally, studied economics and mechanical engineering. I have been professional gamer before and have been on the, I'd say, entrepreneurial train for the last 15 years. So built, scaled, exited companies. Before founding EMMI, was CEO of Small PDF, one of the largest companies, bootstrap companies in Europe, in the document management value chain, as an example. And then 2 years ago, I had the luck to meet Johannes, which is the brain behind everything what we're doing, and professor at the JKU, led the large-scale simulation group at Microsoft Research, and was responsible for the Aurora weather model to apply all the learnings that the guys had in weather modeling, and ultimately moving from numerical methods towards data-driven AI models in weather modeling towards engineering. And this is where we started with EMMI. So we very much have a fundamental approach towards the problem. Deep learning methods, frameworks, and then very large-scale models. And happy to talk more about it, Michael, in the podcast.
Fantastic. Yeah, thank you. By the way, I am looking at comments. If you guys listening in the audience wish to make questions to either of them, please do so. Asparuh, tell us a little bit about you and about Keyword.
Sure. Yeah, first, it's a pleasure to be part of the podcast. Yeah, the topics are very interesting for me as well. My background is mechanical engineering. As most of the people in our company, we come from mechanical engineering background. And this is for half of my career, and essentially around 10 years ago, I switched more focus into data science, computer vision, and essentially that's how we started Keyword. We were coming from the aerodynamics background in the automotive field, and yeah, we saw this potential to use all this data to train surrogate models that can do these evaluations much faster. However, during the process of building those surrogate models, we discovered another problem in the industry, that actually many companies, they do have the data, but it's scattered everywhere, and it's siloed, it comes in many different shapes. And many companies have difficulties making something useful out of their data. And that's how we actually started our platform, Keyword Hub, which is tailored for engineering and data-heavy industries, and with the main goal to break data silos, unify scattered data coming from a variety of solvers or sensors, both from R&D, testing, production, and essentially replacing ad hoc manual workflows with Excel, Python, and yeah, all these more isolated tools.
Some of the people listening might not know what the difference is between like a physics-based model and a surrogate model. Maybe you can just give a half a second explanation. Because I think you guys are, Dennis, you're more working on the fundamentals, right? Whereas Asparuh is doing the surrogate stuff. Is that correct?
I mean, more on the workflow and automation for us.
Yeah, and I think so. There's a natural, I think, evolution, right? Whereas I think in my head, surrogates are always models that solve one problem for one company and let them optimize whatever they want to optimize. I think the path towards foundation models in engineering is, I think, what we're trying to pave with the tech that we have. So go further and train models that kind of cover a whole engineering domain.
Asparuh, did you had a definition for us, I think.
Yeah. Yeah. Can you repeat the question, please, to me?
Well, just
one more time.
What's the difference between physics-based models and surrogate models?
Well, fundamentally, surrogate models are kind of the name says it, a replacement for the physics-based models, trained on data, can produce much faster results. Now we have this buzzword of physics-informed neural networks, which essentially tries to tie both data-driven and physics-based into the same thing.
Okay. No, it's just because I think that there's I mean, AI is moving really fast, but I think the simulation space is moving super fast too. So some people in the eyes might not be caught up. I put in the comments of the post. I put a link to what I published yesterday ahead of this call, which was my top 5 trends in simulation. And the first one I think is more what EMMI AI is trying to solve, right? The physics informed neural networks replacing the traditional solvers. Is that correct?
So I think
We talked
I
about
think
that before the call.
generally speaking, we love to go one step ahead. So physics informed neural network means that you still have some sort of partial differential equation within the models, which on the one hand is amazing because you can guarantee kind of physics consistency, whatever you wanna guarantee from a process perspective. But when you want to train models that are extremely large scale, that generalize across a variety of parameters, usually the physics informed approach doesn't make a lot of sense because it constrains the model with the compute that you basically have to use, and it primes the model tying towards the equation that you're trying to solve and not the generalization capabilities to enforce from a deep learning perspective. So you ultimately lose a lot of the transformer architectures give you by constraining the architecture towards specific physics. So what we're trying to do is fully move, so basically say that transformer architectures replace numerical solvers of physics methods, but so that you utilize what has been proven in vision and language, scaling towards very large scale models that have big breadth and depth in terms of intelligence, and that way are really capable to generalize across, for example, the geometries or input parameters, because that's ultimately what you want, right? To make repetitive revenue and to disrupt the industry.
Okay, thanks, Dennis. And Asparuh, I think you're more on the AI powered workflow, right? Because you were talking about how you're working on ensuring that the data flows well between the different disciplines.
Correct. Right? Correct. So, I mean, not entirely AI powered. We do use a lot of AI agents to help automate mundane and boring tasks, such as setting up templates for analysis and all those things. However, in our platform, we put the focus mostly on the engineers, and we empower them with these AI agents to do faster processing of their data, faster analysis, come faster to insights. But we don't provide them with a replacement for some of the tools.
Okay. So if we go back in time for a minute, you remember back in 2022, 2023, when GPT-3 came out, LLMs became a household word, and most of us had never heard of those before. You guys probably had, but I mean, I think I might have vaguely heard of them. Some of us were very skeptical. Some of us were very bullish right away on the AI thing. And there is a sort of bubble effect. We're kind of waiting for that burst to happen sometime this year. But where did you guys sit in when it first burst, the whole open AI announcement? Where were you guys really enthusiastic and super bullish on it, or were you a bit skeptical?
I was in Europe when it happened. So, I mean, and obviously being a deep learning, machine learning community, you ride on this wave of excitement because you see what capabilities it, from a visionary and pioneering perspective, brings to you. I think, reflecting to engineering, what is clear is that we haven't seen yet this GPT moment in engineering, right? And I think there are a lot of companies who are trying to break through this moment that then it all builds the trust and enablement to really replace classic and standard workflows and partially the incumbents or the numerical solvers to create the value that you need to increase engineering velocity.
How about you, Asparuh?
I agree with Dennis. So when ChatGPT came out, I saw it definitely as a must tool. And I do believe that if we had started Keyword now, essentially what we did for the first 2 years or a year of Keyword, we could have done it probably in a week or 2 weeks with such powerful models that exist today. But yeah, it definitely helped with a lot of mundane tasks. I'm an engineer and / data science and developer, and it really helped me a lot with even polishing emails or writing those things that are not really my thing. It really excelled in that ChatGPT. But as Dennis said, we're still lacking the same thing for engineering. And we believe that partly is due to the architectures of the models, but I think it's to the large part because of the data that's out there to train these
Well,
models.
there's that, and there's the complexity of CAD in general, right? Because it's such a complex data model. But that's a nice segue, because you mentioned you're a developer. Like, the whole vibe coding thing is quite a quite a trend on the web, and I've got a lot of friends of mine that are vibe coding at the moment, or I think the name has changed now. How has AI changed the way you guys are both developers? So how has AI changed the way you develop? How are the teams at EMMI AI and at Keyword leveraging AI? Are you guys still in the copilots? Are you guys using Claude Code? Has Agile been modified to some degree by using AI? Are you bringing agents to your Scrum meeting now? I mean, I'd just like to get an idea of how the changes that are happening there.
Having agent Scrum Masters talk with agent product managers. Go ahead, Asparuh.
That's what I'm thinking is going to happen. I mean, already the PRDs are written by agents, right? And nobody sits down and writes a 20-page PRD anymore, do they? Go ahead, Janice.
No, I mean, I think for us, we have the luck to, and a bit to, as far as reflection of, maybe having started earlier, you would have kind of done it differently, to be a company that is very deep tech. So we develop our own architecture, model architecture, we develop our own framework. So naturally, these models that do kind of more, I'd say, standard software engineering, like that you refer to, Michael, of the Cloud Codes of the world, they do help you, but not much. I mean, I'm not sure if you try to develop a very complex product on vibe coding platforms. Good luck.
Actually,
this is the more specialized you go, the less they are of help at the moment. So, I mean, obviously we utilize everything that we can, but we are more trying to think and apply what's possible towards what we're trying to break through. And for that, we have a lot of PhDs in the team that are ultimately working on fundamental modeling technologies.
Yeah. Okay. So it has had an impact on the development.
100%.
How about at Keyword?
Well, I agree. It has definitely had impact on the development speed, but as Dennis said, mostly for tasks which are kind of classic and typical software development or data processing tasks. But when it comes to R&D and really discovering or architecting something new, that's where these models cannot really do the brain work for you, especially if you want to innovate. But in terms of the software development part and packaging everything into a product, it definitely has helped us a lot. Yeah.
Well,
and
has
as you
it
said,
changed
here these as well.
Has it changed the way? Well, we were talking about it yesterday about on the other call about how there's some industries that absolutely have to have a V, right? They can't really get around the development V. And then traditional software, we've had this agile thing with the milestones and the scrums and everything. It seems to me that AI is going to transform that. It can't possibly be one of those models. There's going to be some hybridization. There's already been a lot of hybridization. But how do you guys see that? Like I facetiously, but at the same time, I think it's sort of real. I said maybe we've got an agent that comes to the Scrum meeting, or maybe there's a bunch of agents having their own Scrum meeting and then giving us a summary of what they did. How do you guys see that happening?
Well, it's a tough one. I mean, I think so, as much as I wouldn't like to fly a plane that hasn't been physically tested, I wouldn't like to use a software that has been programmed fully by AI without a human in the loop. So I think where it can help, and this is very much what we're trying to facilitate at EMMI, is the two task where human brain power is just too much and has a negative ROI on executing it. And Asparuh kind of reflected, right, to the email detail description, last to have, whatever you name it. That is just fucking boring, and it's not worth the money to actually do this stuff. But when it's really about being creative and doing fundamentally new, innovative stuff, it it doesn't help you, because this is, as and this very much relates to, I think, AI and engineering, right? These machines, as big as they are interpolation machines. So they will not figure out anything new that you've trained into it. It can maybe draw a relation between two data points that you haven't seen before, but it will never be capable to invent something new. And I think this applies to how we're integrating it, right? So if you want to do something new, and I mean, this is, as a startup on the VC train, our daily bread and butter is to be the company that disrupts the incumbents and that innovates. So if we do something that an LLM can do, we'll do wrong things because they can just replicate it tomorrow. And it's a bit how we're trying to think of, AI enhanced work that we're doing here.
Asparuh?
Yeah, my view is similar. I don't think that product development and this V-shaped standard form of product development will be fully autonomous by agents. First of all, because I wouldn't go on an airplane that was fully autonomously designed by agents, at least not until now, and I don't see it coming in the next couple of years. I think that agents will enhance and let engineers focus on this really engineering brain work that's interesting to every engineer who's in the field, and automate everything else, like extracting information out of documents, putting it in a presentation, all these things. I believe this is where the agents and AI can shine to optimize the workflow. And yeah, hopefully in the future, maybe we see major breakthroughs and things become even more autonomous. But I still think engineers will be essential. Human will always be there to supervise.
And when a customer is using EMMI or keyword, where's the AI actually being used? Is it something part of the user interface? Are they interacting directly with an agent, or is it part of the plumbing in the application? I mean, where is the AI embedded in your work?
So our products that we sell is the AI. So I mean, I'm not sure, Michael, if you tried the molding demo or injection molding that we released yesterday, right? So ultimately, what we do there is we create an AI model that is capable to give instant physics feedback on any type of geometry, process, material parameters in the whole plastics injection molding value chain. So envision the AI taking the input that naturally a numerical solver would take and giving the output that a numerical solver would put out, ultimately, at the breadth and the depth of a whole engineering domain and in seconds. So it's in engineering, what we call engineer, but not in a sense of we want to replace the physical engineer. It's more like the little helper that does these things faster, that for now the math took years to process, doing it in seconds so that your iteration loops run way faster.
Yeah, and for us, the chatbots are, or not only the chatbots, the AIs are integrated into the platform in different modules, different parts. We have bots that help our engineers with creating reports. We have bots that help our users with generating Python code if they want to quickly evaluate something that we don't provide as a no-code functionality. And yeah, we generally don't allow the bots to do the engineer's work, in the sense that we don't let the bots interact with the user's data, but they give the code to manipulate the user's data so that users can understand what's actually happening behind the scenes.
So there's some kind of an audit trail in terms of what actually happens?
Yeah, absolutely. You can trace everything. I think that's one very important thing with AI for engineering, that you need to be able to understand what's happening and why is this decision taken. And yeah.
Well, I think another aspect that might be difficult to work people's head around is the fact that AI is very probabilistic, and engineering extremely deterministic. So how do you guys put guardrails around it to make it more deterministic? Just a ton of MD files, or maybe some other logic, or maybe a committee of agents before a decision is taken? I'm wondering how you guys get from a probabilistic model to a deterministic result, because obviously simulation is deterministic, right? Fundamentally.
Yeah, and I think this is one of the biggest challenges, I think, from an architecture perspective that we encounter. And the way how to solve it, or how we're solving, is to create ways how to uncertainty or certainty quantify the results that the model ultimately gives the engineer, to then have a judgment call of, does it hallucinate or not? And what you can do to get there is a kind of diffusion-like approach. So, I mean, just to picture this a little bit, have an AI model. So give the same input to the AI model, have 5 outputs generated, compare the outputs to each other. If they are fairly different, and I'm oversimplifying, right? Then the certainty is low, which means that you have high uncertainty. If they are fairly similar to each other, then the certainty is high, and it's a result that you technically would want to recommend an engineer to use.
Okay, interesting. How
Similar
about you?
to when you go to the doctor's office and you don't want to go to one doctor, you would like to go to a couple of doctors, get different opinions, and
Have opinions.
see if they're like, yeah. For us, I mean, it's the same thing. If we talk about the machine learning models that users can train on their engineering data to do their predictions, as Dennis said, you can provide uncertainty quantification and measure this. And as an engineer, as a user, if you see high uncertainty, that means not really, I cannot really trust this. Yeah, and for the other bots that we have, the other agents that we have inside of the platform that help with the actual data manipulation and the workflows automation, for them we provide a large amount of context, including the knowledge base based on the customer's data. So customers can feed their engineering domain knowledge to the agents, and the agents can use this information as a context to what they're doing. And of course, you also always need to provide where this information comes from, what was the source. Yeah, basically try to make it as traceable as possible.
Maybe adding to what Asparuh said, I think one of the things that we're trying to work on a lot, and I think this accounts to any startup in the field, is to build trust on top of AI or applied AI in engineering. And as we haven't had this GPT moment, there is still, specific in large-scale organizations and large industrial companies, there is reasonably so, I think, a high amount of distance towards, trust towards these models. But as the models get bigger, as they get more feature-rich in terms of being capable to have this uncertainty quantification, I think if you ask the same question 2 years, I'm pretty sure that 50-60% of the people are actually using these models. It's just really a matter of time to get there.
And in terms of the models, are you talking exclusively about the off-the-shelf commercial ones or the open source ones? If a customer's using Keyword or EMMI, are they able to bring their own because they already have Anthropic or Gemini or whatever? Or are you also thinking of using some of the open source models with LM Studio or Llama or Microsoft Foundry in order to have a very trained local model that's not polluted with the stuff that might be in Reddit or stuff like that?
Yeah. Well, Keyword is mostly focused on the data part, and we do provide the platform. In the platform, we provide the ability for users to choose which framework they want to use, and they can bring their own models. They can use PyTorch, they can use TensorFlow if they want to. They can use open source models from Hugging Face, or third-party providers, could be even EMMI AI. So yeah, Keyword is more focused on providing the tools for mechanical engineers in an easy-to-use manner to use models with their data.
Yeah, and I think for us, it's, in the engineering domain, if you look at the process of engineering, there is no open model that helps you to do this. in terms of building a product and getting an understanding of the physics, right? So you cannot use anything that is out there because it's very much built for context, text, audio, and video understanding. So we build these models ourselves from start to the finish that then you can use to, I don't know, put a geometry in, get your external aerodynamics out, or put your material in and get your filling pattern out for the injection molding, or put your, I don't know, car in and have it smash virtually against the wall so they get an understanding of how it crashes ultimately. So we're very much focused on building our own models that are capable to, say, replicate true physical behaviors.
So it's like you guys are building your own, but it's not really a large language model. It'd be more like a large simulation model or a large EMMI model.
We
How
call
does
it
that
a large
work
engineering model, but exactly. So this is what we're doing, right? So and these models are meant to be kind of your digital helper, your digital engineer for the engineering domain that they're built for.
So how do you position yourself against like an engineering co-pilot like Leo AI, where Mo Auer, he basically took all these engineering textbooks and trained this thing on them, and then put a sidecar on Onshape and Creo, and now the engineer has this assistant next to him saying, "Don't design it like that." Is it a similar idea but for simulation, or completely different?
I think we're very orthogonal to that. So if you look at the way how you create a car, which I mean, to generalize, I would more apply to the CAD domain, right? So this is where studying the textbooks and having an understanding of how you create it ultimately from a design perspective is very helpful. But then how do you evaluate what you've next to putting it into kind of a CAE tool that helps you to understand the physics? And this is where we come in. So I think naturally, and maybe I'm oversimplifying a little bit, you would create a car with what you described in terms of the shapes and the CAD and the materials, and then you put this into an EMMI model that gives you instant feedback of how it behaves, both from lift and drag coefficient, from crash testing perspective, from a thermal perspective within the engine. So this is what we're doing.
So like in the case of Keyword, you guys are competing more against like orchestrators like Synera or somebody like that, or SimCenter, or maybe the Ansys Discovery platform, which is sort of, no, not at all.
To be honest, not really. We used to develop our own models. We still do occasionally for some cases, but we are more of a platform. If you're familiar with Databricks, kind of pipeline data processing orchestration, but very specifically designed for engineering and manufacturing workflows. So to be honest, I'm not familiar if there is a similar tool out there on the market that does exactly what we do. We kind of find the data engineering, the data processing, and the surrogate modeling into one platform. And yeah, that's what we do. Synera is more of a, as far as I'm aware, more of an orchestration tool for multiple CAE tools that you can build a workflow and call these and execute these workflows, where Keyword is more designed for mechanical engineers who want to do machine learning, who want to do more data-driven analysis in a more automated way. And the platform can process any CAE solver out there that produces data out there.
Awesome. And I guess for EMMI, where the competition sits where exactly then? Because you guys are building your own model, so it'd be closer to a neural concept or something like that, or like Ansys Discovery, just a whole platform.
No, so I think the neural concepts and the physics X of the world, they're more on the platform game of trying to replace Ansys for the engineer. Basically are two layers below that. So on a framework level, we're competitors to an NVIDIA Physics Nemo and Autodesk NavPack, right? So I think this is very much the framework of the technology that helps you to create the AI. And on the level above, on the model layer, we don't really have seen anyone yet. I think it would be more maybe the Project Prometheus guys that are the closest to what we do there. Exactly, but these are the ones. Exactly. So this is more the direction that we have.
So you think that OpenUSD will emerge as a standard that'll sit on top of that?
Say it
Because
again,
I think
Michael.
that's what it's going to be built on ultimately, right? Uh, my understanding of Prometheus is sort of the multiverse, right? It's the physics-informed multiverse, and I think the standard for that is OpenUSD. That's the standard that NVIDIA and PTC and Siemens and DS have all signed on to as how do you do how do you connect the physics, the IoT stuff to create digital twins, right? And then have a closed loop to get the feedback.
So I mean, so we know quite some peeps within there, and I think what they're trying to crack the foundational intelligence layer for engineering. So I think they're even one layer below of what you're describing, and from what we can judge from the outside, I think they very much as well go the route of data-driven models. They're not at all, at least from what we know, on the physics-informed side of what they want to create. And maybe this is tied at the beginning more towards the Bezos type companies like Blue Origin, etc. They really have to go into external error, kind of mechanical stresses specifically for space. So I think this is the reason why we, when we develop what we develop and then challenge it to the market, they are usually the ones that we see the most.
Interesting. Well, sorry, those are sort of unscripted ones, but I just find it so interesting that we're really hitting a lot of the edges where nobody's really gone before. We're sort of the Star Trek already, right? In terms of like the future, so we've been 4 years into the AI revolution now, right? We've seen ChatGPT 3 and 4 and 5, and now we've seen Claude Code and Claude bots, and that's Moltbook, whatever that is, and are you guys as skeptical or bullish as you were 3-4 years ago? And where do you see it going? Because I guess, Dennis, you already said you're waiting for engineering's ChatGPT moment. Does that happen in 2026? Does it happen in 2027?
I mean, so I think that happens in 2026, but
Dennis?
it happens it happens in domains. So what is different from language to engineering is that it doesn't make sense to build this one model who does it all, right? Because the physics, no matter where you start, being it at the generative design part or you're more on the CAE part of solving structural mechanics, whatever you solve for electromagnetics, is very different from domain to domain. And this is why I think we have very much an approach of focusing on these specific use cases, but then go as generalized as possible. So we will see the first foundation models in engineering this year.
Wow, that's pretty bullish. Asparuh, do you agree?
To be honest, I'm maybe a little bit more skeptical about how AI develops. My opinion hasn't changed since GPT is out. I just think that there is a lot of hype, definitely from what I see from being in the industry and talking also with clients in the industry. I agree with Dennis that there will not, engineering is fundamentally different, that in the sense that there will not be one universal model that can do everything. I think that partially the reason for this is that data for engineering is not as abundant as text online and images online, and it's just difficult to train such a large model. So I do agree, future is probably more focused foundational models for specific problems. When we will get to this, to a model that really can generalize well for a case, will be great if it's this year. Let's see. But I just think it will take a couple more years.
But do you guys also think that we're going to see the design and simulation and design and manufacturing that time compressed? Because it seems to me like that you've got all this work on simulation, but we've also made a lot of advances in CNC programming and tooling and 5-axis machines, and those things, if we're going to accelerate time to market, those things have to happen almost simultaneously. They shouldn't be, I have an engineering thing, I give it to the simulation guy, wait a month, he comes back with something, and then I pass it over the wall to manufacturing, and they mess with it, and they come back to me 6 months later saying, actually, that doesn't work. It's just not efficient, right? And I keep talking to these companies, and there's this huge wall, right, between manufacturing and engineering. Shouldn't AI be destroying that wall and just flinging us all together? I mean, I know you guys are more on the simulation side, but you've mentioned manufacturing a couple of times. There must be a lot of fundamental physics. There is a fundamental physics in terms of machining and milling and operations like that. So what do you guys think? Do you think also we'll see a much more compressed time frame where the engineer has to be multidisciplined? He's got to be able to do, or she has to be able to do both design, but also think about the physics and the manufacturing, the simulation. Sorry, I'm going on a long time with the question, but I think you see where I'm going. You want to try that one, Asparuh, and then Dennis can jump in?
Yeah, so I do think that AI will have impact in terms of increasing the speed at which products are developed, and will reduce the time it takes to develop, design, and also to manufacture a product. I think partially this bottleneck comes also from the way companies work. I find the engineering field not as data-driven as financial in the financial sector. Like machine learning, AI, data-driven tools have been used for a long time there, and in engineering, I think people are just starting to change their approach to how they analyze data. And I think AI can support them in this transition there. I read like some time ago, I read an interesting report where basically with LLMs, with ChatGPT, you are able to do 10 times more code, for example, but spending the time to actually fix the code after when it fails in production can be also counterproductive. So it's important how AI is also being applied by the companies to really boost their efficiency.
Dennis,
I think so. Our view is, I think ultimately you need to, and I think it's very parallel to what you've seen in LLM. I think you first want to reach a level of intelligence and crack kind of the foundational layer, being it in generative design, like being it in physics simulation, being it in PLM. And what will happen afterwards is that, and I think this is very much what and the likes are trying to do, and I think will be successful doing so, is you try to then create this in an agentic way so that these kind of elements can talk to each other and you have references, right? And then kind of the whole automation and being capable to run a workflow from A to Z basically starts. But the stage that we're in at the moment is that we're trying to break through this foundational layer of intelligence of one domain or of each domain to then be capable to replicate this across the whole workflow.
Interesting. And so related to that, then the younger, I look in the demographics of people watching this podcast, I do have a lot of entry-level people. And so there's a lot of anxiety on how AI is going to take their jobs. What do you think they should be focusing on, this younger generation of engineers and why should they work for startups instead of for the big three? That's another one I keep forgetting to ask. Because I mean, obviously you want to get the best brains working for your startups, and that don't go to NVIDIA and Dassault and Google. And so maybe I turn it that way. Like, what's they learn, and why would they go work for you guys and take that risk rather than working for a safe, boring place like Facebook, you know?
Yeah, I'm estimating how good startups are paying, to be honest.
Okay. Well, yeah.
Go ahead, Asparuh.
I mean, you say it, Michael, boring job at Facebook or Meta. I usually say, if you want to learn politics, go to big companies. If you want to learn the domain and the skill set, go to a startup, and you just be encountering so many problems every day. You just learn to think fast and how to solve every problem that comes your way. I personally have always preferred this way of working. And I think for young engineers or young people coming out of university with AI around, that's the way that you are going to get valuable experience that will make you irreplaceable by AI. I do believe you need to adapt and use AI tools. I find that young people coming out of universities really do struggle right now because I personally don't need 5 juniors right now to assist me with my work because I'm using AI. But still, there is need for juniors, and they're going to learn more when they work in a startup. It's just fast-paced environment.
Dennis?
Yeah. I mean, ultimately, I think, I don't think that AI, and we see this in any other domain, will replace people fully, right? I think the way we work will change, and the velocity of what we input and output in our work will increase with the help of AI. But as long as you stay curious, I wouldn't worry, to be honest. If you get lazy, it might be different, right? But I think that really depends on your personality that you have. I think generally speaking, I mean, we are super lucky of being in a phase where, if you have great talent, and great talent kind of recognizes the speed of what is happening at the moment, they want to work in startups to learn fast, to have high velocity. So we're extremely happy to have the people that we have in the team.
We have one question coming in the comments from Victor Rosa. He says, thanks to both of you for your insights. What is your assessment of the current landscape of benchmarks around AI physics models? What are the challenges towards standardization of the models coming from the open source versus commercial communities?
Yeah, happy to take this one. Well, yeah, Asparuh, go.
Because it's your question, I think, Dennis.
I mean, I think for us, honestly,
I think it's more on your side.
It's great to have these benchmarks, to have a way how to measure accuracy and model capabilities. But what we do see with, being a driver ML, being a driver net, being at the new kind of error benchmark from NVIDIA, that are all great benchmarks in data sets, is that are very narrow in terms of applicability. So they are great to, I'd say, benchmark surrogating capabilities, but they're not good to benchmark foundation model capabilities. So I would love to see broader, bigger data sets that actually cover full domains rather than, very narrow data sets that are more kind of toy problems, if you want to say it this way, that really help you to benchmark, true capabilities rather than little features of certain models, AI architectures, etc.
Yeah. Thanks. Anything to add, Asparuh? Or we move on?
No, I fully agree with Dennis. It's the benchmarks are good as orientation, but they're not really objective always. And a larger database, a larger amount of engineering data being open source can really help creating better models. Architecture plays a bigger role, but I believe data plays a larger role.
Data is always the central linchpin to all of this stuff, I think.
Mm-hmm.
So let's switch gears to digital maturity and enterprises. So when I created the podcast, it's because a friend of mine said I should do it on AI, but I thought, well, nobody wants to hear me just talking about AI, and no customer's going to come on and tell us what they're doing with AI. But talking to you guys who are customers, and probably you can give me a better feel for what's actually out there. So when I look at AI, I think of a spectrum from 1 to 5. I think of 1 is I'm still using email for most of my collaboration. I'm still using Excel for 99% of my bombs, and just about everything is Excel and email. And 5 would be fully autonomous, agentic, adaptive digital twins, and nobody's at 5, right? I mean, almost nobody. So in your experience and the companies that are buying EMMI and Keyword, are the companies you're working with closer to 1 or 2? Are there anybody at 3? I mean, how do you assess without naming names, but in general, where do you see your customers in terms of their maturity?
Go ahead, Asparuh.
Dennis? Oh, his video might be frozen. Asparuh, you want to take that?
Yeah, I'll take it. So maybe until 2 years ago, I would say the majority of the companies we were talking to were at 1 or 2. Very in the beginning, some of them were just starting to get on the AI wagon, mostly because of hype, be it on LinkedIn, social media. And what made me an impression is that from last year, from the conferences that we were attending, I see that more and more companies have already done some initial projects. They're a little bit more aware of the challenges with AI models, such as everything surrounding getting your data, preparing your data. And I still encounter companies that still haven't started, but let's say that those are right now maybe 10-20% of the companies we interact with, and 80% have already started with some POCs, so they're at stage 2, level 2 or level 3.
So they're passing 2 and heading to 3, basically.
Yeah, yeah. Very few are at stable level 3 going to level 4.
Okay. Is that your same experience, Dennis?
Yeah, sorry for the internet. I have no idea
okay.
who's I don't know, cutting the cables here. So I think as we are more on the fundamental level, I think I would rate our customer kind of projects more on 3, 4, and maybe scratching the 5 at the moment. So I think the most advanced AI and models we're building are really models for controlling large-scale engineering processes and systems to optimize them. So ultimately, to use kind of this real-time inference to inform, I think the network models to steer large-scale products, being it I don't know, from chemical systems, kind of the rotary kilns and the processes that you have there, towards kind of grid capabilities that you have. So these models exist, but they are very rare and they're not common, I would say, at the moment. So we're definitely moving towards the 4, 5, but in very specific cases where you have enough data and where you have enough value for the money that you need to train these large-scale models.
But I suppose that means that there's just part of the company that's that advanced, because I don't know if there's any company that the entire company is that far along, right?
I believe that Dennis was referring to the maturity of the technology.
And I'm talking about the companies, your customers'
Sorry,
maturity.
then maybe missing this one. So I mean, on the customer side, I'm with you.
Thanks,
so I think this definitely is not far down the road. I think we have maybe to make a bit of a example. I think there are very few companies who actually approach us with a problem that they want to solve with AI. They mostly approach us with the intent to include AI in their processes, which can be very painful because you become the McKinsey for them, and they'd rather pay the consultants. But yeah, no, fully agree.
So my thesis is that putting in AI-powered awesome software like Keyword and EMMI is a catalyst. It's a way of moving the needle to the right, and that the big three are all kind of floundering, and they're absolutely not delivering state-of-the-art, bleeding-edge AI functionality today. So how, in your experience, how have you seen that? Have you seen a customer have an aha moment or an epiphany when they were using Keyword or EMMI and said, "Holy cow! If I break my data silos and I have data governance, I could actually get so much more and actually really innovate and digitally transform my enterprise into something that's far more powerful." So have you actually seen that in action in your experience with customers?
Yes, that's actually one of the most satisfying parts. I'm personally constantly in touch with the customers. I'm usually onboarding them on the platform and teaching how to use it. And for many of the mechanical engineers, it's a new way of looking at data. Usually in the typical engineering workflows, engineers would do one simulation or one test. They'll look at the measurements. Maybe they'll put it in a PowerPoint report, but they'll forget it. And what we provide is a way to collect all this data, put it in one place, have a full overview, analyze it more kind of like a big data, look more at trends, spot patterns, identify hidden knowledge gaps that you haven't talked before. And usually when we have a trial with a company starting from one user, very soon after the people start interacting with the platform, suddenly there are 10 other use cases from other teams that can be explored. And yeah, that's it's
So
a
my theory is
satisfying moment.
my thesis is validated. How about on your side, EMMI?
Same thing. I mean, we actually, I think most of the customers we have had failed projects with others before on the problems they're trying to solve.
Oh, okay.
So it's kind of the classic thing of over-promising, under-delivering. So this is usually from a technology perspective how we then come in, try the challenges, break through the challenges, and then kind of have happy customers afterwards.
So you really, do you feel that just the fact that you guys are so AI native, that's what's giving you such a wedge against the DASO, against Simulia and ANSYS, SimCenter, all that stuff. It's just your agility but how do you compete against the big guys? Is it basically on that agility and that being closer to the customer as well, understanding really their pains?
I think for us, it's more on the capability side of things, right? Because I think it's just very different what the big dogs that have reasonability to sell their seats kind of put to the market. The way how AI will impact this whole thing is so different towards what they can offer and what they're selling. But because how do you want to sell an AI model or AI capabilities on a seat-based license? Like, this doesn't make any sense. So you have to fundamentally rethink the way how you price, how you productize. And given the margins, the reach and the market grab that all of they have, they, I think, are not incentivized to change towards this kind of structure, which kind of naturally or inherently is an issue and allows us, being deep learning native or AI native, however you want to describe it, with the capabilities and with the speed that we have, to just hardly compete.
Interesting. Same experience on your side?
For us, we definitely have the speed advantage. We work and make decisions very fast. We have iterated for the last 4 years to find a product that really meets users' needs. And we are just capable. If I have to give concrete examples, I was at a conference last year, and one of the company's major software vendors stated their roadmap to develop a specific agent in their platform that we actually developed 2 weeks earlier, and it took us approximately 2 weeks from prototype to being in production. And in their roadmap, this was announced for something that will come next year. So the speed is much higher. Yeah, and I think that's the main advantage towards the big guys.
That's really fast. EMMI, how about you guys over at Dennis? Sorry.
So, I mean, I think that the good thing is tying towards, in terms of the technology that we develop, we are very orthogonal to the big dogs. So we see the same. I think in terms, we have a 30 people organization that 25 people are developers and research engineers, and we're trying to interact super fast. And I think that's the reason why we're capable to shoot out all these kind of foundational things with a very slim org, being very efficient and effective with what we do, compared to multiple layers of management, all structures, products that you have to maintain. Like, we basically have a head start by building from scratch.
So, like for EMMI, how, like, from meeting the customer to deployment, is it like what Asparuh is saying? Is something in a matter of weeks rather than a matter of months or years?
So I think it's more a matter of months for us, at least, because let's say the time to generate the data, train these models, implement these models, obviously take time. But if an incumbent would do that, I think it would take them like years to get there.
Sorry, Asparuh, what were you going to say?
In our case, it's instant, because we provide a platform that if we give you credentials now, you can instantly log in. And depending on your use case, if we're talking about a 3D deep learning use case that they want to train, it can take a couple of weeks until they have a trained initial model. If we're talking about time series models or tabular data models, we have delivered value within a day, within 2 days even, to companies that they already have a model that gives them good results.
It's really incredible because the big three, you could be waiting a considerably longer amount of time for less of a result, right?
Oh yeah,
And have
absolutely.
two zeros at the price tag.
Exactly.
Well, that's fantastic. That was really awesome, and it was interesting to see Dennis, you're working more on the fundamental layer, and Asparuh, you're working on making sure keeping the data clean between the process. Really complementary solutions, actually. Did you guys have a good time too?
Yeah, thanks for taking the time and grilling us.
Where can we see you guys in the next couple months? Are you guys coming to Threaded in Warwick, for example, the best startup conference in the tech world?
I heard it's Florida, early April.
Yeah, there's Miami too. Threaded Miami and Threaded Warwick. But seriously, where are you guys going to be at CDFAM? Are you going to be at any? Can people come and meet you at any conferences in the next couple of months? Other than my conferences, of course.
I mean, we'll obviously be there. No. I mean, I think for us, we are more on the deep learning kind of conferences.
Okay.
So the NeurIPS, ICML type of conferences at the moment. So
Thank
I mean,
you.
feel free to come by. And otherwise, always in between Berlin, Paris, and Vienna and Linz. So happy to meet for coffee.
Or beer, like we did with Keyword.
Or schnitzel.
Schnitzel. How about you, Asparuh?
For us, we are mostly actually focused on the engineering conferences. We'll be participating in NAFEMS, I believe ASES, then there are a couple of other automotive and manufacturing conferences we're going to this year, but to be honest, I don't know all the names. I will be at NAFEMS and at probably Florida with you, Mikael. And otherwise, we're also based in Berlin. I'm currently in Berlin, but we do have also offices in Amsterdam and Paris, and in the US in Colorado. So yeah, I'm also open for a beer or a drink. Dennis, if you're in Berlin, I'd love to have a coffee with you and talk how we can collaborate.
I didn't know you were there. Otherwise, I would have come when I came for Radiohead back in December, which was a fantastic show at the Uber Arena. To the audience, thank you for joining. We had about 15, 20 people. You guys feel free to reach out to Asparuh and Dennis if you have questions about EMMI AI or Keyword. And we'll see you on the next podcast. Tomorrow, I have Manukai and Productive Machines, so we'll be switching back to the manufacturing side after having a little tour of the simulation side. So thank you very much, and we'll talk to you on the next AI Across the Product Lifecycle podcast. Bye-bye.
Thank you.
Okay.